Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maharajan University, Rohtak. So today I will discuss a new topic, Legendre polynomial. And in Legendre polynomial, same as it is like power series. So we will use power series method here. So let's begin it, Legendre method, right? Okay, this is your two questions here, two or three questions here. This is your power series solution method question. So you will solve this question and tell your answer with my answer, right? Now, Legendre equation. So first Legendre equation, then I will tell you about Legendre polynomial. So the differential equation 1 minus x square d2y by dx2 minus 2x dy by dx plus n plus 1 of y is equal to 0. So that equation is called Legendre equation, right? 1 minus x square d2y by dx2 minus 2x dy by dx plus n plus 1 y is equal to 0 is known as Legendre equation. And the above equation 1, you can write it d upon dx 1 minus x square dy by dx. You can see here that if you will apply u into v rule, then 1 minus x square d2y by dx2 minus, that means 1 minus x square differentiation will be 0 minus 2x. That means you will get your second term, right? So we are considering that the solution of this equation is y is equal to summation r is equal to 0 to infinity a r x to the power m minus r is the power series of x, right? This is, we can see here that if you will expand this function in this series, then you will get the answer in your power in powers, right? Now find dy by dx, same as in our previous session. So dy by dx will be summation r is equal to 0 to infinity a r x to the power n, formula will be applicable here. So n x to the power n minus 1, so m minus r into x to the power m minus r minus 1, right? Now second step, we need d2y by dx2 here. So d2y by dx2 will be summation r is equal to 0 to infinity a r m minus r, then again x to the power n, differentiation of x to the power n formula applicable. So nx to the power n minus 1, that means m minus r minus 1 x to the power m minus r minus 2, right? Now we have all our values. So substituting all these values in equation 1 here. So 1 minus x square summation r is equal to 0 to infinity a r m minus r minus 1 x to the power m minus r minus 2 minus 2x uh, summation r is equal to 0 to infinity a r m minus r x to the power m minus r minus 1 plus n plus 1 into y means this value, right? Now next step, just calculation here, just we will do just two or more, three more steps to calculate this value. So you can see here that summation r is equal to 0 to infinity, this term means 1 minus x square. So we are multiplying this term inside the bracket. So after multiplication, you will get second term will be your x to the power m minus r minus 2 into x square, and minus 2 this term, and this term we are writing same as it is, right? Now in third step, this term and this term same as it is, but here minus 2 and base are equal, power can be cancelled. So minus 2 and plus 2, that will be your 0 power. So x to the power m minus r will be remaining, and this term same as it is, right? Now here you can see that x minus r, x to the power m minus r minus 1 into x, 1 plus 1 and minus 1 both will be cancelled out. So this term will be remaining here, right? Now, okay, summation r is equal to 0 to infinity a r m minus r minus 1, this term minus this term. So we can see here in our next term, last in last line, you can see that this power x to the power m minus 1 coefficient is this one, x to the power m minus r, x to the power m minus r, a r. So what we can common, we can take outside summation r is equal to 0 to infinity a r x to the power m minus r. So we are doing this step as it is. Here we are taking common r is equal to 0 to infinity a r x to the power m minus r. So when it is outside, then your value will be this one. Right now, next step, here this term same as it is, no change. Here you can write it because this is positive term, so you are writing positive first, then negative term. So here you can see that m minus r common in the both of the terms. So just taking m minus r outside, so 2 plus m minus r minus 1, so 2 minus 1 will be 1 here. So this term n plus 1 minus m minus r plus 1 will be remaining. So this is your equation 3. Now next step, equation 3 is an identity and coefficient of various powers of x must vanish. So now equating to 0 the coefficient of x to the power m from the above equation. That means we are just equal to 0 the coefficient of x to the power m. That means you are putting r is equal to 0 here, right? So x to the power m coefficient is summation n plus 1 minus m minus r plus 1. This term is the coefficient of x to the power r. Right, when you put m plus r, m minus r is equal to 0, sorry, m minus r is equal to 0, so x to the power m coefficient will be remaining. Right, so n plus 1 minus m minus r plus 1. Here ar, when we are putting r is equal to 0, so a naught is equal to 0. So you can see here this term a naught does not equal to 0. So this value, this term can be equal to 0, because if your a naught is equal to 0, that means जो हमारी series है उसका first term ही हमारा 0 हो गया. That means r is not starting from 0, right? So our hypothesis is saying that r is starting from 0 to infinity. So hypothesis will be wrong. Now, a naught does not equal to 0, but this term is equal to 0. Now, just solve this term. So, r is equal to 0. We know that here. So, just put r is equal to 0, then you will get this equation. And you can write this equation as n minus n plus m plus 1 is equal to 0. So, we have m is equal to n and m is equal to minus n minus 1. Right? Next, x to the power m. After then, you will compare the term coefficient is equal to 0, x to the power m minus 1. So what will you do when you will put r is equal to 1? Then you will get a1 n and 1 plus 1 minus m minus 1 m is equal to 0. So just find a1 n plus m. Just after solution, calculate these terms. So you will get a1 n plus m n minus m plus 1 is equal to 0. Now you can see here that m plus n minus m plus 1 is equal to 0. So you can see in our previous method, we here this term here, you can see that m is equal to n. If m is equal to n and m is equal to minus n minus 1 already is done here, then here what we are saying, n plus m, n minus m plus 1. We have n is equal to minus m already, right? So this term can never be 0 because n is equal to minus m. So a1 should be 0 here because this bracket is not equal to 0. So coefficient a1 will be 0 here because our condition, this condition and this condition, this one, that means this condition and this condition, equation 4, both are not matching. That means by equation 4 we can say that this does not equal to 0, so our coefficient a1 will be 0. Right, now again to find a relation in successive coefficient ar. So when you find equating the coefficient of x to the power m minus r minus 2 is equal to 0. So our equation is, last equation is x to the power m minus r minus 2. Coefficient is this one, a r m minus r minus 1. Now here m minus r coefficient, that means r is replacing by r minus 2. So r will be replaced by r minus 2. Here also r will be replaced r minus 2. So you can see here that this term plus n plus 1 minus m minus r minus 2, m minus r minus 1, and r is replacing by r plus 2 is equal to 0. That means in x to the power m plus r, you will replace r is equal to r plus 2, right? When you compare, equating the coefficient of this is equal to 0. So m minus r, left hand side same as it is, right hand side just r is equal to, sorry, n plus 1, so you can write n square plus n minus m minus r minus 2, minus 2 you can write minus 1, and my m minus r minus 1 ar plus 2. So this term can be m minus r minus 1, you can see that we are multiplying this term inside the bracket. So it will be m minus r minus 1 whole square, minus minus 1 will be positive, m minus r minus 1 ar plus 2, right? Now this is your, just minus is outside, so multiply inside the bracket. So this term is my negative, so minus minus will be positive, minus minus and minus minus, ar plus 2. Just to solve 2 or 3 more step here, we have, what we are doing, m minus r minus 1 whole square minus n square, and this term here, order 2 term is coming together and order 1 is coming together. Now a square minus b square is applicable, so a minus b, a plus b, and these terms will be same as it is. Now you can see here this term is taken common outside, so just common outside and you are getting this equation. So our target is to find ar plus 2, so you can write ar plus 2 is equal to this term upon these two terms, right? This is very easy, but calculation is hard, so just do your calculation yourself and be carefully. Now next, if you have ar plus 2, then you will put r is equal to a naught, you have already know that, right? So a1 is equal to 0, we have already calculated, so you can calculate a3, okay, you can calculate a3 from here, this equation. From here a1 is 0, we are getting a1 is equal to 0, so a3 you can calculate easily. So a3, that means you will put r is equal to 1, so a1 will be here, so a3 will be 0, a5 will be 0, that means all odd terms r will be 0, all odd terms will be 0 here. Now case 1, we have already find m is equal to n. Here we can see that we have a condition m is equal to n here, so just use this condition. So when m is equal to n, so just write ar plus 2 is equal to, write the value of m is equal to n in this equation, put m is equal to n in this equation, then you will get this term, right? Solve this equation and put r is equal to 0, so a2 will, you will have a2, then r is equal to 2, then a4, that means you are finding all even terms here, and so on. And when you put a1, a naught, a1, a2, a3, and so on, a4, a5 in your final solution, that means this solution, y is equal to summation x to the power m plus r, this solution. When you expand this and when you put all these value here, then you will get your next step, right? So this is your final solution, y is equal to a naught x to the power n minus 1 upon this one into this one. So this is very easy, but calculation is hard, so be carefully, do you be careful, right? Now our, we have our second case, and second case is when m is equal to minus n plus 1. So we have, if you write m is equal to this values, and then you will get a2 is equal to a4 is equal to, so your solution will be like this. Now Lysander polynomial, so there will be 7.5 marks question will come in your semester exam related to Lysander polynomial. So what is Lysander polynomial? So Lysander polynomial is p n x is equal to 1 upon 2 to the power n into n factorial d to the power n upon dx to the power n x square minus 1 to the power n. So this is your Lysander polynomial, right? Now if n is equal to 0, then p naught x is equal to 2 to the power 0, 1, 0 factorial d to the power n dx to the power n, that means that will be 0. So power 0, that means all value will be 1 here, and 0 factorial is 1, 2 to the power 0 is 1, so p naught x you have to remember as 1. right? Now, if n is equal to 1, then p1x is equal to this one, d upon dx x square minus 1, that means 1 time is differentiation. So 2x upon 2, that means 2. So p1x is equal to x. If n is equal to 2, so p2x is equal to this value. So d2 upon dx2, that means double time derivative we are finding. So for 2 square, for 2 factorial 2, d2 upon dx2 x square minus 1 whole square. So apply double time derivative form. So d upon dx, when you time first time differentiation will be 2 x square minus 1 into 2x. Then again u into v will be applicable. So just apply u into v, then you will get p2x is equal to 3x square minus 1 upon 2. Similarly, we can find P3, P4, P5, and so on. Last, P and X. So P and X will be summation R is equal to 0 to capital N minus 1 to the power R, 2n minus 2R factorial upon this one. So these value is your polynomial, Legendre polynomial, and capital N is equal to n by 2 when n is even, and odd n minus 1 by 2. So I will discuss one example related to this topic in our next session. So today is sufficient that Legendre topic. So guys, just prepare your topic. Thank you.